Hello students. In this chapter 11, we're going to very briefly talk about some physical properties of solutions. This is also called colligative properties. So specifically we're talking about when you have solutions, aqueous solutions, and that means when you have some solute dissolved in a solvent, and in this case, for this chapter we're going to consider them aqueous solutions, so we're dissolving them in water. So already in this course, we have seen how we use molarity, capital M, to measure and report the concentration of a solution. And we know that molarity is the number of moles of a solute that are dissolved in a liter of solution. So it's the number of moles of solute per liter of solution. But this is not the only way that we've learned to measure or report concentration of a solution this semester. In your lab course, you work with concentrations reported in mass of solute dissolved in a volume of solution. For example, when you did the copper ore dilutions, you had milligrams per milliliter. And so there are other ways that we can report or measure concentrations of solution other than just molarity. The one I'd like to talk about right now is called molality. So it's very close to molarity. And the only difference in the spelling is that it does not have an R here, it has an L. So it's not molarity, it's molality. And where molarity is represented with the capital M, molality is represented with a lowercase m, and that is written in italics. So it's a lowercase, swoopy sort of m. And that's to distinguish it from mass or meters. So we have molality. And molality is exactly the same as molarity in the numerator. So it's the number of moles of a solute, and then it is divided by a denominator, and the denominator is what is different. It is not liters, it is kilograms. So it's not a volume, it's now a mass. And it's not of the whole solution, it is now just of the solvent. So molality is the number of moles of solute dissolved in a kilogram of solvent. So it's the number of moles of solute per kilogram of solvent. So with this in mind, I've got a sample problem for you here. And this sample problem asks for you to calculate the molality, and you're going to use this equation right here. Calculate the molality of a solution of sodium chloride, and we know the formula for sodium chloride, right? It's NaCl. Sodium chloride formed by adding 23 grams of sodium chloride to 540 milliliters of water. And you might say, wait a minute, you've given me the volume of the water, but don't I need the mass of the water here? And we've given you a conversion factor. We've given you the density of the water as a conversion factor. So assume the density of the water is 1.00 grams per milliliter, and we will treat that as an exact density of exactly 1 milliliter so that it does not limit your sig figs. So go ahead and work through that problem. Calculate the molality of this solution when you add 23 grams of sodium chloride to 540 milliliters of water, and assuming that the water has a density of 1.00 grams per milliliter. So go ahead and pause the video and work through this problem. And when you're done, resume the video and come back, and I will work through this problem for you. Okay, so we know that molality is the number of moles of solute per kilogram of solvent. So let's have our general equation here. Molality equals the number of moles of solute per some number of kilograms of solvent. The solute in this case is the sodium chloride. The solvent is the water. So I need to have a value that I can plug into the numerator, and I need a value that I can plug into the denominator. So I'm going to set each of these up as separate problems. I'm going to determine what the moles of the solute are, and then I can plug them in the top. Then I will set up a separate problem to determine the kilograms of solvent, do those conversions, and then I will plug those in there. So I'm just going to make some space over here, and eventually I'll come back and I'll plug in those values when I have them, right? So right now I need to figure out how many moles of solute do I have. Well, I'm going to do a mass to mole conversion. So I say 23 grams of sodium chloride, and I need to calculate my molar mass of sodium chloride, and if I calculate it up, I've got grams per mole. This is a molar mass conversion, so that's per 1 mole, and it's 58.44, 3 grams per 1 mole. And I do the canceling, and I cancel out the grams, and I'm left with moles. And my answer, rounded to 2 sig figs, 0.39 moles. And now I have my moles of the solute. So that goes in the numerator, 0.39 moles of solute. Okay. Now I need to figure out how many kilograms of solvent do I have. So I'm going to start with 540 milliliters. And I'm going to convert those milliliters first to grams using my density. Then I'll convert the grams to kilograms. And then I will have my kilograms of solvent. So the density conversion says that it's 1.00 per 1.00. And then we have 1,000 grams per 1 kilogram. So if I do this math, so I have 540, and this is 1 over 1, so that doesn't really change anything. So 540 times 1 equals 540. Divided by 1,000, I'm going to get 0.54, rounded 2 sig figs, so I do not take it out to the extra 0. And that is kilograms of water, right? From 540 milliliters, it's 0.54 kilograms. So now I have the number of kilograms of solvent, 0.54. And we know that molality is the number of moles of the solute divided by the kilograms of the solvent. So if we do that math, we get 0.39 divided by 0.54, and we get 0.72. And we don't forget our units of measurement. And it's the nice swoopy M that represents molality. So what is the molality of this solution? It is 0.72 molal. It is a 0.72 molal solution. And there's my answer. All right. So molality is a different way to calculate the concentration of a solution. Now this becomes very important because colligative properties, that is the physical properties of solutions, depend on the concentration of the solutions, and specifically the concentration as represented in molality units. Okay? And we're about to see that in our next video, where we deal with colligative properties. All right, that's all for now.